Hi, this is Dean from SYX. This is a video explaining about the Optimiser low limit alarm. Okay, so I've established a web connection to my controller. I've set up my network address and I am talking to the controller on 192.168.1.99. We can do this in the engineering level browser, which is without the MO switch, or we can do it with the MO browser as well. I'll just type that in just to show that there's no difference. We can log in user 2. Okay, and we're presented with the red flashing triangle showing us that there's an alarm on the system. This will be also represented on the controller with a flashing alarm LED. So the same information applies, and it's the same discussion that we have to have. This really is to emphasize the point that this is not a fault with the controller per se. This is the controller informing you, the engineer stroke customer, that there is a potential issue with the energy usage of the system, and that you are basically consuming, or would be consuming, far too much energy, which is out of standard. Based upon experience of using this controller in many applications. Buildings tend to warm up at different rates, obviously based around the fabric, the heat sources, the temperatures available, the type of plant, efficiencies, all those sorts of things, especially set points as well. But typically set points are achievable. If a set point isn't achievable, then the Optimiser, which is the piece of software which decides when to start and stop the plant, will come on earlier and earlier and earlier in order to achieve a set point ready for occupation time. If the set point cannot be achieved, then the Optimiser will come on earlier the following day in order to give itself a better opportunity to hit the target set point by occupancy time. And so we end up in a situation where the Optimiser can calculate a warming up rate, which is based upon the number of degrees C the temperature in the space will increase in an hour. So if we end up with a rate of rise which is less than 0.5 degrees C per hour, that would equate to 2 hours of heating to raise the room temperature by 1 degree C. Now, I think if you did that in your own house, you would feel the pinch of the cost of running that fuel through your radiators in order to try and achieve a set point that clearly isn't achievable. So what we do is we raise an alarm to let you know that this is not normal. And so if we look at the alarm, it comes up with some information that says SYX 660 heating temperature control, Optimiser low limit, and Optimiser low limit. So it's not exactly the most clearly explained reason for the alarm, but that's why we're doing this video. You can confirm the alarm when you've logged in at user level 2, but you cannot delete it because at this moment in time the alarm is still active. So the message is still current, but now it's stopped flashing because you're taking responsibility of it. So to clear the alarm, what we do is we click on the heating menu and we go to values, and we drop down the menu list until we find a parameter called the building warm-up rate. And as you can see, that has dropped below 0.5. Now then, what are the fundamental reasons for a low warming up rate? Well, it could be that the boilers have failed and there is a problem with the heat source. So maybe out of 3 boilers, maybe 2 are unavailable. They've got faulty. Maybe the pump's not working. Maybe the actuator is not opening the valve for the variable temperature circuit. Maybe there is a thermostat which is disabling the fan convectors inside the space of the building. Maybe the radiators have got air in them. Maybe the thermostatic radiator valves have been turned off. All of these things will prevent the space from warming up at an acceptable rate, or they will prevent the target set point from being achieved. For example, if the Optimiser is looking to heat the room to a set point of 22 degrees, but there is an underfloor heating circuit in the building and there is a thermostat controlling the underfloor heating, and the thermostat for the underfloor heating is set to 20 degrees. By that rationale, the heating for the underfloor heating would turn off at 20 degrees, and the optimizer would not be able to achieve the target temperature of 22. The optimizer would therefore carry on coming on earlier and earlier in order for it to achieve its target set point. This is where the building warm-up rate will continue to reduce to a point where it will go below 0.5 and then generate the error. But as you can see from the discussion, that the reason for the alarm is not to do with the controller, it's to do with the controller not being able to achieve the task it's been set. So in order to remove the alarm, what we have to do is put the building warm-up rate back to a standard level or an expected level of rate of rise. Now the warming up rate is based upon degrees C per hour. So let's think about different types of buildings here. If we've got a very, very old building which has got quite an inefficient low temperature heating system, then the building warm-up rate will be a lot longer than what it would be for a much more modern, thermally efficient building. So the optimizer will adapt itself to the characteristics of the building based around the room temperature sensor's performance, and the room temperature sensor's performance is going to be affected by the flow temperatures, the heating system, and the types of emission that the room sensor is presented to. So, for example, an air handling unit will warm up a space a lot faster than a radiator system, or an underfloor heating system, for example. So we have to take all these characteristics into task, and that's what the optimizer does, and it will adapt the building warm-up rate to suit the performance of its particular building. So in order to clear the alarm, what we have to do is set this back up to a default level, which is typically something in the order of 1 to 1.5. I'm going to put this one to 1. And that will then clear the alarm. You can see we've got a flashing green icon now. We can now click on that icon and we can click on confirm, and we can delete that particular alarm. So the alarm buffer is now clear. The task at hand now is to identify why that particular building warm-up rate was achieved. So this could be due to a situation of building fabric. Maybe there was a window left open. Maybe there's a very ineffective radiator where the room sensor is located. Maybe there were problems with the plant. Numerous reasons, and that's what we need to identify. If we don't identify the reason for the slow warming up rate, what will happen is the alarm will reoccur probably in about 7 to 10 days time, and we'll be faced with the same discussion, and we will have to identify the same or maybe a secondary reason. So it's good to eradicate all the reasons for a slow warming up rate. So check that the boiler thermostats are set to the maximum permitted flow temperature. Check that the radiator, if they've got thermostatic rad valves connected, make sure where the room sensor is connected or where the room sensor is located in the building that the TRVs are set and left to maximum. Make sure fan convectors are working if it's a fan convector system. Make sure that thermostats for underfloor heating systems are set to a set point which is greater than the set point that the optimizer is looking to achieve. We cannot have a thermostat which is set below the target room temperature of the optimizer. For obvious reasons, the optimizer needs to be able to achieve its target set point. A good rule of thumb about what is achievable with the system you've got without making any alterations is to look at the temperature log of the heating system. So I'll just quickly do that on the controller. We can look at the room sensor. This is just a simulator at this moment in time. What we've got here is the ability to look back in history and see what was the achieved set point. What was the building able to achieve with the heating plant running at maximum output for a good period of time? And this will give us an indication of what to look for, what is throttling the performance of the heating system. So if the system was working flat out, everything was working well, but we only achieved 19 degrees, then that will be your target set point in that location, and that's what you should set it to, because we know the optimizer can achieve it. Okay, so with all those settings made, that will then clear the optimizer alarm, all being well. If there is something out of characteristic that we need to achieve with the optimizer, but we are unable to identify problems with the plant, what would be best is to hold the adaption, set it to a sensible level, maybe 1 degree C per hour or something like that, and then you can go to the heating system, choose switch, drop down into the setup mode, and you can set optimizer adaption to be disabled. That will give you some breathing space to resolve the issues if they're a bit more time than is imminently available, or maybe there's some funding that needs to be found to resolve the issue. So disabling the adaption will stop the optimizer adapting below a low level. So those are the discussion points to go over, but we remain available to discuss any of these points and provide additional guidance should you need to discuss it. So please don't hesitate to get in touch. Thanks very much.